Hey guys, welcome to your 4.1 notes on analysis of functions, determining where they increase, decrease, and their concavity. So the first part of this section is going to focus on strictly intervals of increase or decrease. And we will apply theorem 4.1.2. If f is a function that's continuous on a closed interval, and differentiable on an open interval, then if your derivative, which remember, your derivative is just the slope of the tangent line. So if the slope of your tangent line is greater than 0, then it's increasing on the closed interval. So notice it is closed here, even though we're only checking the open interval, and we'll discuss why in more depth in class, but let's just accept this is true for the examples in the video. So if the slope of your tangent line is less than 0, then you're decreasing on the closed interval. And if the slope of your tangent line is equal to 0, then it is constant on that closed interval. So let's get into the first example. So find all intervals of increase and decrease for the given function. So first, in order to determine where it's increasing or decreasing, I need to find my derivative, the slope of my tangent line. So for number 1, f prime of x is 3x squared minus 12. So that is the slope of my tangent line for any x value, and we're trying to determine for when that x value is greater than 0, less than 0, or equal to 0. So usually the first thing we want to start with is setting it equal to 0, because that is where the important value or the distinctions happen between positive slope, 0 slope, or negative slope. So 0 equals 3x squared minus 12. So if I am trying to determine whether it's greater, less, or equal to 0, I can do some sign checking. So first I'm going to factor 3, and that leaves x squared minus 4, which factors to be x plus 2, x minus 2. So I need to determine where this is greater than 0, less than 0, or equal to 0. I am going to go ahead and do this all in one step by doing sign checking. So if I set these equal to 0, x equals positive or negative 2. So I know here, negative 2, positive 2 are going to be my important points. So if I am checking my signs, I know they are 0 here. So let's see at less than 2. So if I plug in a number less than 2, let's say I'm checking x equals negative 3. If I plug that into this equation, I have 3 multiplied by negative 1 multiplied by negative 5. So I see that it's going to be positive from negative infinity until 2. What about from negative 2 until positive 2? Well, that's easy. I can let x equal 0. You can pick any number in that interval. And here I'm not even going to focus on the values, just the signs. So I'll have 3, which is a positive, multiplied by 0 plus 2, which is a positive, and 0 minus 2, which is a negative. So this is negative from negative 2 to 2. So now I need to check greater than 2. I'll let x equal 3. So first 3 is positive. 3 plus 2 is positive. And 3 minus 2 is positive. So we see it's positive or positive slope from 2 to infinity. So let's see, where is our graph increasing? So it's increasing Now remember, our rule is it's increasing on the closed interval. Now infinity is never included, so it's negative infinity until -2, including that endpoint, union with +2 until infinity. And it is decreasing on the interval from -2 until 2. Now I know it doesn't feel right to have these closed intervals here for intervals of increasing and decreasing, but we will talk about this more in class. And we want to make sure that we have all of this work shown proving that we've checked our signs to determine these intervals of increase and decrease. Let's try the next example.